12 kilometers beneath the Earth's surface, that's the deepest humans have ever drilled into our planet before the Earth itself began pushing back. At first glance, digging deeper seems simple. Build stronger machines, spend more money, and keep drilling. But the deeper we go, the more hostile the planet becomes. Temperatures rise beyond 200 degrees Celsius, metal bends under immense pressure, drill bits shatter, and solid rock begins to behave more like soft plastic than stone. Yet, the most surprising discoveries weren't the extreme temperatures. Scientists found water where none should exist, strange gases trapped deep underground, and geological formations that completely challenged what experts thought they knew about the Earth. Today, we're exploring just how deep humans can go beneath the surface, and what lies in the mysterious world below, where no human has ever reached. If you've ever wondered why we haven't drilled straight through the Earth, the answer begins on the remote Kola Peninsula in northern Russia. For decades, engineers worked tirelessly on what would become the deepest hole ever drilled, the Kola Superdeep Borehole. Everything went according to plan for the first several kilometers, but as the drill approached 12,000 meters, things started to go wrong. Scientists expected temperatures of around 100 degrees Celsius. Instead, they measured nearly 180 degrees Celsius. The equipment simply wasn't designed for that level of heat. Imagine a drilling system consisting of hundreds of tons of steel pipe descending kilometers into the earth. At the end of it sits a diamond-tipped drill bit designed to slice through granite. Under normal conditions, granite is hard but manageable. At extreme depths, however, the rock behaves differently. Pressure exceeding 1,000 atmospheres squeezed the walls of the borehole. The granite became almost plastic-like, slowly flowing back into the opening after drilling. Every time engineers removed the drill bit for maintenance, the earth would begin closing the hole behind them. Entire sections often had to be drilled again. It became a constant battle against the planet itself. The deeper the team drilled, the more unpredictable conditions became. Steel pipes twisted under stress. Drill strings snapped. Equipment failures often meant losing months of progress. When broken tools became trapped several kilometers on the ground, retrieving them was nearly impossible. In many cases, engineers had no choice but to abandon the damaged section and start drilling a new path nearby. What shocked scientists most wasn't the technical difficulty. It was the realization that the Earth's crust was far more complex than anyone had imagined. And then came an even bigger surprise: water. At depths where temperatures should have made liquid water impossible, researchers discovered fractures filled with mineral-rich fluids. The finding challenged decades of geological assumptions. The discoveries didn't stop with water. Scientists analyzing samples from more than 6.7 kilometers below the surface found evidence of ancient microscopic life. Fossilized remains of 24 species of plankton were discovered embedded within rocks nearly 2 billion years old. These organisms weren't found near the surface. They were buried deep within some of the oldest foundations of the planet. The discovery suggested that life on Earth may have emerged earlier and spread deeper than previously believed. At the same time, another mystery emerged. Large quantities of gases, including helium, hydrogen, and methane, began escaping from underground. Every new meter of drilling carried the risk of fire or explosion. Workers constantly monitored sensors, knowing that a single spark could trigger disaster. Scientists were beginning to understand that the Earth's interior wasn't a static environment. It was alive with movement, pressure, and chemical activity. As the drilling continued, engineers installed acoustic sensors deep inside the borehole. Their purpose was simple: monitor drilling operations and detect subtle movements within the Earth's crust. What they recorded would later become the basis of one of the most famous scientific myths ever created. Stories began circulating that researchers had lowered microphones deep underground and heard terrifying screams coming from beneath the earth. Newspapers around the world called it the sounds from hell. The reality was much less supernatural, but no less fascinating. Deep underground, sound behaves differently. Under enormous pressure, solid rock becomes a giant resonator. Shifting rock layers, cracking metal, and drilling vibrations created eerie noises unlike anything heard on the surface. Later investigations revealed that the infamous screaming recordings were fabricated. However, the genuine sounds captured by scientists were still extraordinary. They were listening to a living planet constantly moving beneath their feet. At times, strange acoustic events occurred that initially baffled engineers. In one case, the drill suddenly dropped into what appeared to be a large underground cavity where solid rock should have existed. The resulting pressure changes produced sounds so unusual that some researchers initially struggled to explain them. Eventually, they discovered a geological zone filled with highly pressurized gas. The mystery had a scientific explanation, but it demonstrated how little we truly know about the world below. The Kola project revealed a difficult truth. Reaching the Earth's mantle from land might be nearly impossible, so scientists came up with a new idea. If continental crust is too thick, why not drill through the ocean floor instead? Beneath the oceans, Earth's crust is often only 5 to 7 kilometers thick. It seemed like the perfect shortcut. In the 1960s, an ambitious project known as Mohole aimed to do exactly that. Engineers attempted to drill into the Pacific Ocean floor from a floating ship. The challenge was staggering. Imagine trying to drill a precise hole in concrete while standing on top of a skyscraper during a storm. Ocean currents constantly pushed the ship off course. Even small movements could bend or break the drilling equipment. During one test, a powerful underwater current nearly destroyed the entire operation. Only quick action by the ship's crew prevented catastrophe. Later projects became even more ambitious. Japan's drilling vessel Chikyu used advanced computer systems to keep itself positioned within a few centimeters despite waves and currents. Yet nature continued to fight back. Pressurized gas and superheated mud repeatedly clogged drilling systems and damaged equipment. Once again, the Earth refused to surrender easily. While some scientists focused on narrow boreholes, others created enormous excavations visible from space. One of the most famous examples is the Mir mine in Siberia. More than 500 meters deep, the giant crater is so massive that aircraft are discouraged from flying directly above it. According to local legends, the mine can suck helicopters from the sky. While exaggerated, the story has a scientific basis. Cold air trapped inside the enormous pit can create powerful downward air currents capable of affecting aircraft performance. The mine also produces its own weather patterns. Dense fogs can form at the bottom, while conditions above remain completely different. Similar challenges exist in other giant open-pit mines. At the Bingham Canyon mine in the United States, a massive landslide in 2013 released approximately 65 million tons of rock. The event was so powerful that it registered on seismic instruments like a small earthquake. Despite decades of excavation, humanity has barely scratched the surface of the planet. Even the deepest mines are insignificant compared to the thickness of Earth's crust. Today, the deepest boreholes are no longer found at Kola. Some of the longest wells are located beneath Qatar and Russia's Sakhalin Island. These wells exceed 12 kilometers in length. But there's a catch. They don't go straight down. Instead, they curve sideways, traveling for kilometers beneath the seabed to reach oil and gas reservoirs. Why don't we simply drill vertically to greater depths? The answer is surprisingly simple. Physics. At depths beyond roughly 15 kilometers, steel pipes become so heavy that they risk collapsing under their own weight. The heat becomes extreme, the pressure becomes overwhelming, and the materials needed to continue simply don't exist yet. To go deeper, humanity will need entirely new technologies, advanced composites, autonomous drilling robots, cooling systems capable of surviving temperatures exceeding 300 degrees Celsius. Scientists are already developing concepts for future missions designed to reach the Earth's mantle directly for the first time in history. If successful, it would be one of the most ambitious scientific achievements ever attempted. We've sent spacecraft to Mars. We've landed on the moon. We've explored the deepest parts of the ocean. Yet, the world beneath our feet remains one of the greatest mysteries on Earth. The deepest hole ever drilled reaches only a tiny fraction of the distance to the planet's core. Everything below remains largely unexplored. And perhaps the most fascinating question is this: if reaching 12 kilometers pushed our technology to its limits, what incredible discoveries are still waiting far deeper below? If you like incredible engineering stuff, be sure to like and subscribe for more.